So today, our objective, just like what we did with the interest problems that we did yesterday, we're going to use the table again, and we're going to solve simple mixture applications. And then Thursday, we are going to solve more complicated, compound, is what they call them, mixture applications. So we're going to make the same table, except instead of principal and rate, we're going to use A and V. Okay? And then our other column, instead of being our interest, is going to be TV, which is AV, A times V. So just so we're on the same vocab, there's a few vocab words. Amount, that's how many of something you have. Like I have 3 highlighters. That's an amount. How many of something? Now the value would be how much something is worth or cost. Each of those, I would probably guess a highlighter, 25 cents. So the value of this highlighter is 25 cents. The value of this highlighter, 25 cents. And so is this one. So the amount is 3, the value is 25 cents. And to find the total value, I would take 3 times 25 cents. You get 75 cents. You understand the difference between amounts and value? So we're going to be using those vocab words today. So I would always just start making a table. Hopefully I made it big enough. And then your headers, this is going to be your amount, how many you have of something. This is going to be your value, how much it's worth, costs. And we're going to have this be our total value, which equals A times V. So we have our 2 variables, and then our total column that way. And then here, it's going to depend on what we're talking about. And then this is going to be our total. Yesterday we put in on investment number 2. We also put CD, savings. Previewing the problem, at the regional championship for EHS soccer, I'm guessing that's Emporia High School soccer, the ticket masters, that's who sells the tickets, they charge adults $5 for their tickets and students $3. The ticket masters sold 332 tickets and they made around 1,200 that day. How many of each type of tickets did they sell? So my 2 things that will go will be tickets for adults and tickets for students. So we'll call this adult ticket. And this will be our student tickets. Now we're going to read through the problem again. They charge $5 for adults, right? So where would 5 go, you think? Well, that would be amount. How many tickets did they sell? Value would be how much the tickets cost, right? So we are going to put 5 here. $5. And there's $3. Right? Student value is $3. That's how much it cost. And then the ticket master sold 32 tickets. let me think. This is number of tickets, this is number of tickets. So total would be right here, right? 332 tickets. But then they made 1236 that day. That's how much money they brought in from selling all those tickets. Well, if you take the number of tickets times how much they cost, that'll tell you how much they made off adults. You take number of tickets times how much they cost, which is $3 for students. That will tell you how much they made for students. And if you add these two, right here will be how much you total made, right? So I'm going to put 1236 down here. Now the question is, how many of each type of tickets did they sell? So they're wanting to know here. So let's say they sold X adult tickets. We don't know. Now this is very similar to yesterday. Instead of putting a Y, if they sold, say, 10 tickets here, then this would be 322, right? Because these two will add up to 332. So this value will be your total amount of tickets minus how many you sold to adults would then be students. Does that make sense? Now from there, we're pretty much done. We're going to multiply, get this value, and this plus this equals that. We'll solve for x, and then we can find how many adult and how many students. So, first, 5 times x, and then 3 times 332 minus x. This is how much they made off adults. This is how much they made off of students. We know they made a total of 1236, so I get the equation 5x plus 3 times quantity 332 minus x is 1236. And then from there you just solve. Bring down my 5x. 3 times 332, 996. 3 times negative x, negative 3x. And then I have a 5x and a negative 3x on the same side. I could go ahead and combine those. 5 minus 3 is 2. Subtract 996 from both sides. Then you get 2x. And 1236 minus 996 is 240. Divide by 2. And you get 240 over 2, which is 120. So x, 120, would be 120 adult tickets. So so I could say, how many tickets did they sell? They sold 120 adult tickets. And 332 minus 120, but 112? No, 212. 212 student tickets. Any questions on that? Now you may have seen this in AG3, AG2, AG1 as this. I'm not going to solve it. But you'd say x plus y equals 332 tickets. You guys remember that? And then you would say 5 times X, because tickets cost $5 for them. And then say 3 times Y equals 1236. And then the easiest way would be to solve for X. And then plug it in here, and then solve that. That's called substitution. But I want you guys to solve things using the table method. But this way works too, okay? You remember that? All right, example number 2, which is money in my pocket example. Before I start, I like to make a table. Remember, it has 4 lines going this way. I'm sorry, 5, and then 5 going this way. This will always be A for amounts. This will always be V. This will be your total value, which equals A times V. This will always be your total. And then I read the question. Mr. Parker has $6.15 in nickels and quarters, and he has 35 coins in his pocket. How many nickels does he have and how many quarters? So the variables are how many nickels, how many quarters. So I'm going to make this nickels. Just nickels. And this be quarters. Now we're lucky that all he has is nickels and quarters, because if he had dimes and pennies, then this becomes a lot more complicated of a question. So he has $6.15. Where would that go? Any idea? Is that how many total coins he has, or is that how much total money he has? How much total money he has, right? That's total value. And he has 35 coins in his pocket. Well, we don't know how many nickels, we don't know how many quarters, but the total amount is there's 35. It could be 20 nickels, 10 quarters, could be 0 and 35, could be 35 and 0. And then they say, how many nickels, does he have? Well, let's make that X, which would then make this 35 minus X. I don't have enough information. I am missing the value. Does anyone know, without them telling us, how much a nickel's worth? 5 cents. And how much is a quarter worth? 25 cents. So what I'm going to do, I know he has $6.15. If I take 0.05 times X, that's how much money he has worth of nickels. If I take this times that, that's how much money he has total in quarters. Add those two values and it should add up to 615. So I do 0.05 times X, and then 0.25 times 35 minus X. Total value would be this plus this. do some math. 25% of 35 would mean 35 divided by 4, which is 8.75. Minus 0.25x. We distribute the quarter to both. Now you can combine these two. If you have a nickel and you take away a quarter, that'd be negative 20 cents. Bring down my 875. Trying to get x by itself, take off 875 on both sides. And 6.15 minus 8.75 is negative 2.6. Divide both sides by negative 0.2, and you get 13. Now, had I got a number that was like 13.2, then I would know either the problem is flawed or I made a mistake, because you can't have 13.2 of a nickel, right? So because I got a whole number, I feel pretty confident. So the question was, how many nickels does he have and how many quarters? Well, Mr. Parker, Mr. Parker has 13 and 35 minus 13, 22 quarters. Notice 13 plus 22 is 35, and if you take 13 times 0.05 and you take 22 times 0.25, you will get $6.15. Questions so far? And if you were doing substitution or elimination, go x plus y is 35, 0.05x plus 0.25y is 6.15, and then solve for one of the variables and plug back in. Okay. See a few people still copying, so I'll leave. And we'll start. We're done. Sure. You're welcome. I would start off by making a table. Five lines this way, 5 lines this way. You have your A, you have your V, you have your TV, which is your total value. And you have your total. And we don't know what we're talking about yet, so I'm going to read the question. Dum Dum Dugan, very interesting name. He's running a concession stand at the Emporia High School sub-state game on Friday. He is going to be selling hot dog meals and hamburger meals, and they have the prices there. He bought enough hot dogs to make 67 less than twice as many hamburgers. If he spent almost $500 on groceries, how many of each meal can he make? So our two variables are what? hot dog. In real life, I'm sure the concession stand has more than just hot dog meals and hamburger meals. That produces more variables, and you guys aren't quite ready for more than 2. Just so you know. KCA, I taught you how to solve 3. So, I like reading through the question, blah, 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 blah. Hot dog meals are $1.25. So is that amount? How many hot dogs, or how much the hot dogs cost? They cost, yep. And you could put a dollar sign with the $1.25 if that helps. And then hamburger meals